midnight. I will not be here until midnight, just an FYI. I will be here until probably about 8:30, 9 o'clock today and tomorrow for the seminar. If you guys, I would really recommend you guys stop by. I would be willing to bet there's going to be a fair number of people that just want to generally talk about stuff after the seminar. And so if you guys are around to be able to kind of babble off them a little bit, talk about things that you might have experienced yourself, any recommendations you might have, that will probably go quite well. Thank you in advance. That is, of course, paid time for everyone. So if that is something you decide to help out with, we would greatly appreciate it. All right, final project this week. It's a fun one. The cool thing is, the math honestly isn't, oh, okay, I'm not going to say that. Okay, it's math that they've all seen, right? It's nothing new. If they decide to do, there's two methods that they can do for the mid-pass. That's where the math is going to get the hardest for them. If they decide to do the low pass, then a buffer, then a high pass, it's not too bad. It's essentially just taking whatever they did for the high and low pass filters and smushing them into one. If they want a better sound, if they want it to be a little bit more quote unquote, what you would see in more of an industrial situation or what you would actually see in a product, they can go with the RLC version. Using an inductor in series with capacitor and a resistor, and that will get a lot better tone. You'll get a lot more of kind of a deeper sound to that. And if they want to do that, that math does get a little hectic if they decide to go that way, especially since we don't directly tell them how to calculate resistance based off of the bandwidth. That is a relatively well-known calculation. It's online, and it's not too hard. It's the resistance over the bandwidth tells you your quality factor. So if you know your quality factor, you can then determine what you're looking for there. So that's kind of fun. If people are interested in learning that, it's a great little research for them to do, and they can learn quite a bit from that. The biggest things that I saw people miss last semester were the loading resistors. Pretty much isolating your equalizer from your gains from your main summing. And if they don't use those, then you get this wonderful high-pitched squeal going on no matter what tone you're using. And that's due to all of your capacitors just releasing charge at random times. So making sure those loading resistors are first off there and also not like 20 ohms is going to really help with that. I found, as you guys did it yourself, you probably realized that, the lower the resistance, the louder noise you get, but it comes with a lot of static. Right, and often if it goes too low, you get that high-pitched squeal again. If you notice that they're way too high, then you get way too quiet of a noise, even though it may sound beautiful. So finding that middle equal ground, there's not really a good calculation for that. So that's a little bit of trial and error on their side. Personally, I believe I used 4.7K is what I used. That seemed to work out pretty well. But I also used some different values and stuff like that as well. I used slightly different op amps than you guys, but that didn't help at all. So don't do that. 356 is too fine. Please finish your grading. Please. Okay, we got 2 weeks left. And I really don't want you guys to have to be grading while you guys are stressing about your own finals. So please finish this up. It's what we owe to our students. It's so they know kind of what to expect and what they should be. How much effort should they be putting into the final project to get the grade that they want, right? We don't want to think of it that way, but that's the mentality every single person in this room has right now for every single class that you're taking. So don't take it personally. That's what our students are thinking too, right? So please finish up your grading as soon as possible. That way we can make sure that they're getting their information back. Any questions for me? Yes. Yes, we'll be using that for deliverables. So so John made a great document that actually lists step by step what is expected for each deliverable, what do they need to show, what do we need to see, and what are we going to be checking off. That way they have that ready, they can look at that and reference it throughout the project. So we have that for us. So thank you very much for making it. Yes. Yep, I'll make sure everyone has that. I'll be posting on Piazza after Tuesday night. That way people actually have an incentive to stop by and go to the seminar too. Any other questions? Cool. All right, if anything else comes up, please let me know. Adam and Aaron, it's up to you guys.
Yes. So before we talk about the final project, there are a couple of things for this week. Just reminder your students the actual credit 5 is due this week. Okay, and also make an announcement for remind them the final project seminar is today and tomorrow, and also tell them this week we need to start the final project. Okay. All right, so the final project, all of you should already familiar with the project, which just about the equalizer and also the power amplifier part. Okay, so basically this part is the equalizer part, and then connect with there's a mean volume control, and then there's a power amplifier, and then will be the speaker. The power amplifier will be the actual credits part. Okay. Okay, let me talk about it. Okay, let me talk about here. So I already draw this on the board here. So this basically this part is the like mean project they're going to do, the equalizer and the volume control. And then the PA and the crossover circuit will be the actual credit. And that's what been taught on the on the manual. And then this is like the block diagram of what they're going to do. Basically, this part is the filter part, which they learned in the lab 10. Okay, so okay, yeah. In the lab 10, then learned about the filter part. And then the volume control, which they just use the amplifier, which they learned in lab 8. Okay. So let's talk about the specs first. So the filter, the cutoff frequency is like 324 low pass, high pass is 3.2K, and pan pass is from 320 to 3.2K. When you do the checkout or when you check the report, they can have like plus 10 or plus or minus 10% error. Okay, so as long as they are in this range, we can count it right when we do the checkout.
You're welcome to be a little generous on this as well. You can tell that they put the work down and stuff like that. I'm willing to. If they're within 15%, they should probably be within 10% anyway. It's accommodation.
Okay, so for the filter part, okay, first of all is the low pass and band pass. They can just simply use the RC low pass high pass filter. For the band pass one, as Ben mentioned, they can either use this like low pass and high pass combined together with a buffer in between that can be worked by the band pass filter, and also they can use the RLC band pass filter. I think we didn't do this last semester, so for the RLC, because we provide the document, the schematic for them. So all of them use this filter. Probably we will expect a few students using this one, but most of them, I guess, still going to use this one. If they are doing this one, the common mistake for this one is they are using the same value for low pass filter and high pass filter for these two filter. Okay. Basically, they need to inverse the number for their RC and also this RC. So that will be a common mistake for the bandpass filter. I can say probably 1/3 of the students will make this mistake at the first. Okay, and then for the amplifier part, okay, so each amplifier will be the same. I think they can either use and they will I think most of them they will use the inverting amplifier. and which the gain will control by this potentiometer. And then there's a total volume control, which using the sum amplifier, which is like this. They didn't build the sum amplifier in the lab 8, but there is an example talk about the sum amplifier in the lab 8 manual. So you can remind them to review lab 8 and lab 10 for the final project. Okay, so that's the basic schematic of this. I think I will erase this part after our meeting since we don't want to share it.
Also, one other common mistake I remember from last semester is even though it's very clearly shown and explained, you need low pass, buffer, then high pass. Lots of people, for whatever reason, will not put in the buffer. And if you do that, you get like a lot of crosstalk and loading and stuff between your low and high pass. So if they're going that route and they're having issues, another thing we can double check is that they are actually including the buffer.
Does it matter if they do the high pass or the low pass first?
Nope.
Kind of, right? If you do the low pass first, it gets rid of any high shrills that might be going on, which is kind of nice. So that's why I always recommend doing low pass first. Oh. It would, but it will also, but we can talk about it later if you're interested in math. Don't really worry too much about it. It doesn't really matter. If you want it to turn out a little bit better, you can put the low pass before the high pass. It turns out a little bit better.
Yeah. From the WebEx. Right, so that's the filter part. The value they're going to calculate is according to the cutoff frequency. Okay, and then for the amplifier part, okay, so the potentiometer, the value is already fixed since the maximum is 10K. So the thing they can change is the resistor as the input. Okay, so that's what they are going to calculate according to these two specs. Okay, the input is already given is 1 volt VPP, and the weight amp requirement at the maximum, which means when we tune to the potentiometer to the maximum, is 100 milliVRMS. Okay, then they can use the VRMS transfer function to transfer either like weight in to VRMS or weight amp to VPP, so they can get the same unit. Then they can get the total gain for each pass. Okay, so that's the gain will be gain A times the gain B, so that's the total gain. Gain A is the gain for the volume control of each pass, and then gain B could be the gain of the sum amplifier. Okay, so I do the calculation. The gain A times gain B will be 0.282, and one example I can give you right now is they can use R4 as 10K, okay, and then R9 as 13.5K. So that's probably the most common value they will use for the
So just throwing out there as a question, because I don't know.
Yeah.
These problems where they would use that circuit schematic for the loop pass, and they not be getting like a.
Yeah.
Reasonable, but
Yeah.
you know what?
That's because the band pass filter, I think that's the quality of this filter is not that high, so that will make this part is not going to reach exactly 0 dB, probably for like 92 or even 93 dB, even at the top part. So one way I tell the student to fix this is they can make the gain of the band pass filter to be a little bit larger than the other two pass.
Yeah, like, sometimes that would happen, sometimes it wouldn't happen.
Yeah.
So I don't know if it was.
I think one of the reasons probably could be they put the order of the high pass and low pass also probably matter.
It also depends on the op amp, because essentially what you're doing is you're first making, say, you're doing the low pass filter, right? But then you're trying to filter out, or you're trying to get a band of that, but you already just lopped off everything after, say, 320 hertz, right? So all that stuff's at really low power. So even though you're able to filter it out, you're able to make that band, you're at a really small gain at that. So, and that's if you just do a standard inverter like is on the board right now, you're not adding gain to that. You're just putting in whatever or you're putting out whatever you're putting in. So if you bump up the gain on that, usually a gain of 2 or 3 will work just fine if they really want to. I've seen some, one person last semester did a gain of 10. It got out. It was able to get out, and it was really loud. It was just terrible quality. So.
Okay.
Yeah, so, and also this is a good example, but when they do the calculation, okay, so theoretically, they can put this gain A to be very large, then gain B to be very small. So theoretically, that will work, but in the real world, probably that's not going to work. So just make the gain A and gain B kind of close together. Don't make one to be very large and then another one to be very small. Okay, so, and also for this part, as Adam and Ben mentioned, there's a loading issue. For example, if I use this filter here, so I connect the bandpass to the inverting amplifier. It's R4. If this resistor value is close to this resistor value, there will be a loading issue. So if we want to make sure the student this resistor value is much larger than this one. Okay, so that's one way to solve the loading issue. Another way is they can just put a buffer in between. So they will need an actual circuit, but that will also fix it. So either way works. It depends on them. Okay, so that's the calculation part of the whole, I think the main part. When they, let me see. When they build a buffer on the op amp, so there are a couple chips they can use. There are LM324. There are 4 op amp. Okay, so make sure you mention this again. I saw students only use 1 op amp and say they don't have enough chip. So there are 4 op amp in the LM324. And also the LF356, there's all one op amp. I think each chip they have 2 of them, I guess. Then totally they should have 10 op amp or 10 buffer. So that should be enough for their project. I think if they burn out their chip before, they can still get a new one in WE shop. But just make sure you tell them they should have enough in their lab kit.
Another side of that, something that I'm working on in here is actually setting up kind of a mini shop just for 20,007. We do have a bunch of 356s and 324s in here. So if you're in lab, you're welcome to come in here and pick them up. Just only you guys come in here. Don't have students come in here.
It's still the TA room.
That's fine.
Right, so I think that's the general schematic. Since we are not going to provide the document for the whole project, like the schematic of this project right now, they are going to ask questions about how to build each part. So one suggestion is that although we're not going to grade the pre-lab of the final project, for the JTA still encourage the student to draw the schematic and show you probably at beginning of this week. Okay, and then you can say, like, are they on the right track or not? Okay, if they build something or they draw something obvious, like very wrong at beginning, then they are on the right track, on the wrong track. So make sure you check their idea or their plan for the project at the beginning. Okay. I think it's kind of a short period. They're going to start to build the circuit this week, and they are going to check out next week. So basically, they only have 1 week to build the circuit. Okay. So try to let the students start early.
That's also the point of the seminar, just so they can come here, they can have a discussion, the lecture that would be happening in lab. We can do it outside of lab, and that way they have more time to actually do it.
And yeah, and one suggestion why told my students for this final project is build the subsystem first. Okay, after they draw the schematic for the host project, some students will just like build this whole project on their breadboard. but I can say like most of the chance that it's not going to work. So try to start build with each small system. Okay, so what I tell students, they build a low pass filter, they check it. Okay, they can use the FRA, the frequency response analyze, to check if their low pass filter is work as they expect or not. If low pass filter is work, then I tell students to build the amplifier individually, and then they put it here as input, here as the output to check this amplifier is working individually or not. Okay, then if both of them working individually, then I let them to connect these two together and check these two working together is working or not. And then same for each part. Okay, so that's what they show to do with this project. Okay, don't build this whole thing together and expect it's going to work immediately. It's not going to work that way. Okay. Also, when they test their individual subsystem, okay, when they get something work, take a screenshot. Okay, they are going to use that for their report. Okay. All right, so I think that's the schematic. And the one thing I want to, the last thing is about the checkout. So one day doing the checkout, we will have a document to show them. Okay, let me show the document first. Okay, so this is the document we're going to use for the project. So you're going to use this document to check out the group next week during the class. Okay, so I will say if you check each one of them during the class, probably you don't have enough time. So I think what we done last semester, for the filter part, you can let the student have their screenshots ready before the class. Okay. When I did checkout in my section, I let them do the high pass and low pass screenshots ready before, and I still check the band pass one since probably the band pass one is the hard one for this. And then for the other part, probably you want to check during the class. Okay, so so this is the minimum and the maximum, and also the ripple and the amplifier output power. Okay. All right, so, and also there is the individual part for the adder part. I will say if their maximum and minimum both working, and when I check out, I will let the student try like tune the volume control of the bandpass to be minimal. Then I will show see like a curve for their frequency response plot. So then I will say their adders still work. Okay, so if you check each one of them, it's not going to have enough time for the during the class. Yeah.
I think they feel.
Yeah. Okay. Yeah, I think for the menu parts, that's what they need to answer in the report. When they doing the checkout, the main part they are following probably is on the step number 4 and 5 or 6. That's about the equalizer part. For the step number 3, okay, I think that's another common mistake. Step number 3 is asking about the power amplifier. some students will think about this is the op amp in the equalizer part. Actually, the step 3 is the power amplifier.
So when they write the report, are they
I don't think they don't have to follow the order of the menu. I think they just follow the format of the report, but they still need to answer the question. For example, for step 3, I think they can answer their question in the procedure part, which includes all the calculation part, I think, or the theory part. I think either one works. Yeah. Okay. All right, so let's see. One last thing for the checkout part. Okay, I need for this here. So when I think the main thing we concern about for the checkout part, probably after you check out the filter part, you're going to check out the amp power. Okay, when they use the FRA of the oscilloscope, since they can only measure when they do the plot, the unit for the y-axis is in dB. So I do the calculation. The gain they should get for the dB is negative 11 dB. So ideally, they will get a straight line when they get the maximum way amp. Okay. But they will have some wiggle. Okay. So probably they will get something like this. And then, for example, here is the maximum, here is the minimum. And when I do the checkouts, I have this thing, and then I will check their measurement at this frequency and at this frequency. And I can say, is that in the 15 milliamp max range? So ideally, they will add this negative 11 dB. Okay, if they have very low or a very high, then they are not in the right range. Okay, so that's just give you a quick set how to do the checkout. Okay, negative 11 dB is around the right gain. All right. If they done the power amplifier part, I don't think you need. But this you still need to check this first. Then you for the power amplifier part, you just check the output. Let me see. Yeah, you just check the main the frequency response for the power amplifier for the crossover. It could be the high pass, low pass, probably something like this. The high pass probably. That's for the actual gradient. Okay, let me see anything else. Ben and Adam, do you have anything to add on this?
I think that's, yeah. My biggest thing is, again, Aaron already touched on it, but make sure that when they're building and testing things, have them build one small sub-circuit, test and verify, build the next small sub-circuit, test and verify, combine, test and verify. Because if they try and do the whole thing, like, I'd bet a lot of money, if they try and do the whole thing all at once, it will not work. And if they have like a whole breadboard, then it's like, it's not working. And then like you're trying to troubleshoot it, you will spend at least 20 minutes even just trying to figure out what the problem is. Or I guess where the problem is before even figuring out what the problem is and how to fix it. Because if they're like, oh, I have a problem with my low pass filter, that's really easy to go check, and that's a matter of minutes. So again, please really stress that with your students this week.
And when you're working with students this week, again, please be conscious of how much time you're spending at each station. We want to make sure each group gets some amount of, or a relatively equal amount of time as they can. On that note, TA hiring is open for summer and fall. If we want to make sure students get adequate time with TAs, please encourage more people to be TAs. You guys did a great job this semester. I greatly appreciate all your work. We need more of you. So please, if you notice students that are doing a good job, please encourage them to be TAs next semester so we can make sure everyone gets a fair shot at having access to TAs. And that'll also decrease the workload on you guys. And you still get paid the same or higher, so win-win.
What time we should put the report due? Final week probably.
So,
Last week semester we done Wednesday of final week.
yeah. GTAs, are we good with that? That gives us about 4 days to, well, what is it? It'd be a total of 5 days to grade final reports.
Final grades are due on Tuesday after final.
Yes. And I would like to have a meeting that Monday, so we're not, running around with our head cut off on Tuesday morning, trying to get stuff submitted by noon on Tuesday.
I guess we
So-
will have a last meeting next Monday.
Yep.
Then probably no meeting on final week.
So. Any more questions right now? All right. Thank you everyone for your time. Greatly appreciate it. GTAs, if we can stick around for a few minutes, that'd be great.
Just don't show to the.
Yes.
No.
I appreciate this.
Yeah, I will.